3 Project 2 assignment. This is the video demonstration for the code. To start, we declare all the variables that we will be using. This step size is the step size for the simulation so that I can choose to have a more coarse or refined simulation by just changing this here. This size represents how many steps I want for the range we'll see below. Here are the ranges of each parameter. As you can see, the size variable determines how many steps are between each range. I chose the steps logarithmically. Here are the matrices where I store the values. Storage in and of itself is just so that it's easier for me to see. What we're focused on is math storage because this stores strings. This one stores the actual numbers, and I can do arithmetic with these. And then I make a call to Simulink to make sure everything passes through correctly. Then I do a test run with the project 1 values to make sure all the formulas were correct. I want to mention, because I mentioned this in the project document too, this worked, but this worked and all the formulas seem to be correct, but as we'll see later, there's a discrepancy between the graphed formulas and the calculated formulas that I believe is due to accidentally including transients. But here's the loop itself. We start with indexing the switching frequency. I calculate the resistance of the switching frequency, and then since the volume is constant, that's always factored in. There's the capacitance. This is since this has dynamic volume, the formula is down here. Same with inductance, and then I tell it to output these values in case something happens, so that I can see where it left off. Then I update the threshold, update t-stop, and tell it to simulate, and then perform the math with all the values that I returned. And then these are the calculated values. And then I have an if statement that does a bit of indexing for me, and then that tells it to update these two, which give me a viable design. Next, I just tell it to display all of these so that in tandem with this up here, I can tell where I left off and what to expect. And then I go down to the arithmetic section. What this does here is it looks through this 8th column, which I label to be the volume, and it picks out the minimum of that, sets it to a variable, and then I get the information from that, and then after that, I get the information from that row. I then update the value. I update these values and tell it to display that as well. And then I send those updated values off to one more simulation. That simulation is more precise than what initially was, just to try and make sure that I'm getting everything correctly. And then I make the call to Simulink. I update the index. I do the last set of calculations, and then I tell it to output all of the values it calculated. This concludes the Project 1 video demonstration. Thank you for your time.